my kitchen. This is a little experiment that you could do also in your kitchen if you had with some common household chemicals, if you happen to have them. This is the relative solubility in a solvent pair portion of the solutions experiment. And the first thing we have here is a tincture of iodine. All right, so I picked this up at the drugstore, and it's used as an antiseptic. Let me talk a little bit about what a tincture is first. To a chemist, a tincture is nothing more than a solution in which ethanol is a solvent. So this is a tincture of iodine, so elemental iodine, I2, has been dissolved in here, as well as some sodium iodide. And if you look at the, I don't know if you can read the concentrations there, it's about 2% iodine and 47% ethanol. And I'll go to the whiteboard and talk a little bit more about that in a moment. So this is the first one. Now iodine, I2, is a nonpolar compound. So one would not expect a nonpolar substance to dissolve in something polar like water. And to increase the solubility of this, we've added ethanol. So ethanol also makes hydrogen bonds. It's miscible with water, right? So in beer, wine, distilled spirits, we have ethanol dissolved in water. So that's what this is. It's 47%, which would make it 94 proof, and it is flammable. I think there's a warning on here that it says caution, flammable. But it's flammable because of the ethanol, not because of the iodine. The ethanol is to help bring the iodine into solution, as is the sodium iodide, and we'll talk more about that a little bit later. So that's the first one, right? So this is a nonpolar substance that's minimally soluble in these polar solvents, ethanol and water. And then the next reagent we'll be using are mineral spirits. This is also a solution. This is a mixture of hydrocarbons. It doesn't really say what's on here. Of course, this is flammable, and it just no, it just says caution, maybe harmful if you get it on your skin, fatal if you drink it, and it is flammable. It's just a mixture of hydrocarbons, so a number of different hydrocarbon liquids all dissolve in each other. So this is our nonpolar solvent. So the first thing I'll do is pour a little bit of the tincture into, hope this is a clean graduated cylinder. Okay, that's quite concentrated. There's a different alcohol smell to it. All right, so this is, if I kind of hold it like this, you can see it's not black. It actually has a brownish color to it, a brownish reddish color. Now, iodine, elemental iodine, is a grayish solid. But I got some on my hands now, so it's stained my hands. Okay. So in order to see this color a little bit better, let me just dilute this iodine with some tap water. There we go. Okay. And you can see the kind of brownish color on the sides of the glass here. Let's just dilute it a little bit more. Okay. There we are. So what I'm going to do now is actually I'm going to place this in this stupid thing off. Place this in a larger volume here. Okay. So there you can see the color of the iodine, kind of a reddish brownish color. So iodine in water has this color. Elemental iodine is a grayish silvery solid, but it's one of these compounds that sublimes. It goes directly from a solid to a gas phase. It doesn't melt. It goes from a gas, or from a solid to a gas skips the whole melting liquid part. And those vapors then, those iodine vapors, and this happens at room temperature. You can, in a bottle of iodine, if it's a clear bottle, you actually see kind of a purple tinge on the glass above the solid, and that's these iodine vapors. So the vapors are purple. Another interesting reaction that's kind of beyond the scope of this, but here we have some liquid starch. You could do this, even if you didn't have liquid starch, you could do this with any kind of starchy food. For example, if you had, had some bread or a potato chip, or even paper towel would work. And this reaction is not important to the lab. If you look online, you'll see people talking about the iodine test or the starch test. And iodine is used to indicate the presence of starch. Starch is used to indicate the presence of iodine, elemental iodine, not iodide, not the I- ion, but elemental iodine, I2. And that's by this reaction. So they put a little bit of iodine in here and swirl that around. Kind of swirl that around. And you can see it's turning purple, right? So this iodine starch test, actually we can take maybe a little bit of this out, and maybe too much. And okay, now it looks black, but it's purple. Okay, you can see on the sides there, the purple color. That's a different kind of reaction than what I'm going to show you next. So I'm going to pour a little bit of the mineral spirits. Pour just a little bit of the mineral spirits into this graduated cylinder. Okay. So that is clear liquid. Definitely has an odor to it. It has that kind of I don't know, gasoline or chemical hydrocarbon odor that tells you definitely it's not water. You'll have to trust me on that because we don't have smell-o-vision yet. But it says odorless. It's less odorless means it's less odor. Doesn't mean it doesn't smell. You can still detect it. All right. So this is the color of just the mineral spirits are non-polar solvent. So what I'm going to do is carefully pour this mineral spirits onto the water, or the tincture of iodine. Okay. So now you can clearly see two layers. Smaller layer, mineral spirits, the iodine tincture on the bottom. We have the polar on the bottom and the non-polar on top. So the mineral spirits layers on top, that should tell you something. Right? So now I've sealed the top so I don't make a mess in my kitchen. And I'm just going to invert this several times and we'll see what happens. Okay, I don't know if you can, again, I don't know if you can see that, but the color, right, I think here now you can. The color of the top layer is now purple, and if I was to keep mixing this up, I'm going to do a little more vigorously now. What I'm trying to do is extract all of the iodine out of the ethanol into the top layer, and I think that iodine concentration is a little bit too high, so I won't be able to get all of it out. But you can see the iodine preferentially goes into the nonpolar layer. Why is that? Why would the iodine go into the nonpolar top layer, the nonpolar mineral spirits, and be extracted from the ethanol water solution? Alright, so I just want to talk a little bit about this tincture of iodine. It's 2% iodine, so that's 2% elemental iodine, and that's usually by weight, so it's 2% by weight. So the mass of the iodine, this is what? This would be equal to 2 grams of iodine for 100 grams of solution. Now sometimes they'll refer to this as by weight, or it might be weight by volume or mass by volume. So it could also be 2% weight. I'm going to use W for weight so I don't confuse the M with moles or molarity at all. So 2% weight by volume. So what this could also be is 2 grams, and they don't tell me on the label here exactly what it is. It could be 2 grams of elemental iodine per 100 milliliters of solution. All right, and of course we have to multiply this by 100. So remember our percent concentration. All right, so 2 grams of iodine per. So our percent concentration is the mass of the solute over the mass of the solution times 100. So the reason we can get away with either weight by weight or weight by volume is because the density of these solutions, if the density of the solution is close to the density of water, right? These are very high concentrations. So if it's close to the density of water, it'll be 1 gram per milliliter. So in other words, 100 grams of the solution equals 100 milliliters. So it doesn't matter if we use mass or volume in dilute solutions like this. All right, so that's the iodine. The ethanol, 47% ethanol. This is usually by volume, so it's a V over V. So I have here 47 milliliters of ethanol, which is our alcohol, in 100 milliliters of solution. Right, times 100, so it's 47 over 100, that's 47 hundredths. Times 100, you get 47%. Remember, percent means per 100. So think of it this way, per cent. Right, we use a percent symbol. Percent means per 100. 100 cents in a dollar, 100 years in a century. So this is per 100. That means we also have 53% water. 53% water. So this is 53 milliliters of water per 100 milliliters of solution, right, times 100. I mentioned in the video this 47%. If you multiply the percent by volume times 2, you get the proof. So this is 94. It looks like a 99. It's 94 proof. 94. Whoops. 94 proof. The proof is twice the concentration by volume. Lastly, we have 2.4% sodium iodide. I don't know why it's acting so goofy. 2.4% sodium iodide. Sodium iodide is a salt, so this would be weight by weight. So 2.4 grams of sodium iodide per 100 grams of solution times 100. Okay, that's how we get our 2.4%. Now the sodium iodide, just like the ethanol, is there to help increase the solubility of iodine. Iodine, elemental iodine, or I2, two iodine atoms bonded together. There's no polarity here. They both have the same electronegativity. So this guy's nonpolar. Right? So it wouldn't be very soluble in water, but we can increase that solubility by, one, decreasing the polarity by using ethanol. Ethanol is not as polar as water, so it's almost half alcohol, so that decreases the polarity somewhat. And then the sodium iodide also increases the solubility by the following reaction. So we have elemental iodine, right, which would be a solid, and it's slightly soluble. I'm going to put here solid. Okay, and then we have the sodium iodide, okay, which is now, it's a salt. It's very soluble, just like sodium chloride is soluble in water. So this will dissolve. But what it forms is something called the triiodide ion. So we get I3 minus and sodium ions. So again, these are ions in solution now, so it would be sodium triiodide. This is the triiodide ion. And this reaction, that's why we use the sodium iodide here, to help pull this iodine, which wouldn't be very soluble, into solution by making it the triiodide ion.